Welcome to FM Tuition Academy. Okay, today we are continuing with a topic that we did part 1, and this is waves. Okay, this is waves part 2, but this time we are dealing with the calculations. Okay? Waves part 2, we are dealing with calculations. Okay, so to understand certain things. For example, you remember what I said concerning the certain type of waves. Let me bring an example. A wave travels from Lusaka to Kabwe at a frequency of 20 kilohertz. K means kilo, okay? Don't get confused. Kilohertz. Find, it's not actually a wave, but I mean to write a radio wave. I was not specific. A radio wave. A radio wave. Okay? A radio wave travels from Lusaka to Kabwe at a frequency of 20 kilohertz. Find the wavelength. Okay. Whenever they give such kind of questions where they ask you to find the wavelength and then they give you an electromagnetic wave, the first thing you do, you write the wave equation. Maybe some of you were not there in part 1 of waves. The wave equation I gave you was velocity is equal to this symbol. It means wavelength. It's called lambda in Greek. So velocity is equal to wavelength times frequency. Okay? So wavelength times frequency. Velocity is equal to wavelength times frequency. So we're trying to make this the subject. So write it as wavelength. Maybe some of you don't know this V means velocity, and then that symbol lambda, it means wavelength. It's a length, and then F, it means frequency. So I'm trying to make this symbol lambda, which is a wavelength. They said find the wavelength. So wavelength times frequency is equal to velocity. I've rearranged it, but I'm trying to find wavelength. So wavelength times frequency is equal to velocity. I have to divide both sides by frequency, even this side by frequency, so that frequency cancels out. What remains is only the wavelength. So wavelength is equal to velocity over frequency. So that's the formula I'll use. Okay, I'll use wavelength is equal to velocity over frequency. Okay, this is the formula I'll use in my calculations. So I'll move. So wavelength is equal to velocity over frequency. So I come to the question. The first thing I ask is, what type of wave was asked? Did they give me the velocity, which is the speed? They didn't give me. They only gave me this part. Okay? They only gave me the frequency. They didn't give me the velocity. So they only gave me the frequency. But I look at the wave. What type of wave is it? It's a radio wave. You remember what I said concerning a radio wave? A radio wave is coming from those 7 waves I gave you from the electromagnetic spectrum. You remember the first wave in the electromagnetic spectrum is radio wave. The second one is microwave, and then there is infrared, there is X-ray, and so on. Those waves, if they give you any of those waves, a radio wave, a microwave, an infrared wave, X-ray, gamma, all those 7 waves, if they bring for you any of them, know that they all travel at the same speed, which is 3 times 10 to the power 8. That's the speed they travel, all of them. So if they give you, they all travel at the same speed. So that's the speed that I'll put here. Even if they didn't give you, that's the speed that we use. So it means it will be 3 times 10 to the power 8 over frequency. You remember they said frequency is 20 kilohertz. In the question, they said 20 kilohertz. Okay? Maybe I've forgotten. This is the frequency. This one here. 20 kilohertz. So how do you convert that? Because of that K, you have to remove the K. So you put your 20 here. Kilo, K means 3 zeros. So I put 1, 2, 3. Haze. Okay? And then those, how many zeros do I have now? 1, 2, 3, 4. So I say 2 times 10 to the power 4. Okay? I'll convert this one. 2 times, I'll convert that one into that notation. So 2 times 10 to the power 4. Why? Because there are 4 zeros now. These ones here. So I will put here 2 times 10 to the power 4. Okay? And then you can use the calculator to calculate this. You can punch that. The answer you get, you punch this, you divide the two answers to give you the answer there. Okay? You write there. But if you want, you can cancel out. Okay? This is the 10 power 4. So 10 power 4 into 10 power 4. When 10 power 4 cancels 10 power 8. You see, if I remove 4, this is 4. When I cancel 4 into 8, how many zeros will remain? 4 zeros will remain. It's 8. So I've cancelled out 4 zeros from 8. So it will be 3 over 2 times 10 to the power 4. Okay? Because 4 zeros have been cancelled in 8. Okay? And then what do you have? So that is 3 over 2 times 10 to the power 4. Okay? There's a dash there. So what do you have? 3 times that one, it will be 30,000. Okay? 30,000 divided by 2. Okay? 30,000 divided by 2. So what is the 2 into 30? It's 15. And then these zeros will come here. You can punch this using calculators. You get a more accurate answer. I'm just teaching you how to go about the calculation. So it's meters because length. This symbol means wavelength. That symbol. Don't get confused. This symbol means wavelength. So it's in meters. Okay? So that's how you calculate this type. Any question that they give you, you solve it like that. Okay? So they can say a microwave stove cooks food at a frequency of 50 megahertz. That time it was kilo, it was K, but now it is M. Find the wavelength. Okay, so by this time you remember the wavelength equation is like this, and then you make wavelength the subject. So V goes this side, you divide by F, this is grade 9 mathematics, and then your wavelength will remain there. Velocity is over F. This is the formula that I'll use, that one. So wavelength is equal to velocity over frequency is equal to, the first thing I check, is there any velocity in the question? Is there any velocity? Velocity means speed. So is there a velocity? No. They have only given me frequency, this one. But what wave is it? Microwave. Microwave, is it part of the waves in the electromagnetic spectrum? Yes. The first wave is radio wave, the second wave is microwave. So it means it also travels at 10 to the power 3 times 10 to the power 8. You see? So that's a speed I'll use also here, because it's also it's part of the spectrum. So 3 times 10 to the power 8 over, it was, the frequency is 50 megahertz. So you say 50 mega, it means how many zeros? Mega, it means 6 zeros. Kilo means 3 zeros. Mega, it means 6 zeros. So I'll put 1, 2, 3. 1, 2, 3. And then, so how many zeros? 6 zeros. And then that side is Haze. Is Haze. So it means 6 zeros. Okay? 6 zeros. So in scientific notation is 50. It is 5 times 10. How many zeros are there? Plus 6 zero here. The 6 zeros plus 1 0, it becomes 7. Okay? Because mega, it means 6 zeros plus 6 0, it makes 7. So it will be 5 times 10 to the power 7. Okay? So that will be equal to 3 over 5. So 7 zeros, when they cancel out in 8, how many zeros are going to remain? 1 there. Because 7 will cancel 8. There will be 110 from the 8. So it means it will be, you can use a calculator to calculate this, in case these calculations are confusing you. Use a calculator. So what you have, times, since you have cancelled 7 in 8, that means 1 has remained. So it will be 10 power 1. Okay? 10 power 1, because, or 10. Okay? So that will be lambda is equal to 30 times 10. A number power 1 is itself, over 5 down. There's 5 here down. Over 5. Okay? So that will be equal to 2 into 5 into 5, 1. 5 into 10 is 2. So 6. Okay? 6 meters. Why? Because lambda is length, it's wavelength. So 6 meters. So it doesn't matter. Have you seen? That's how you calculate. That's the answer. That's the answer. Okay? That's the answer. So sometimes they can bring a question like a sound wave travels at 6 times 10 to the power 5 meters per second, and has a frequency of 7 times 10 to the power 9. Okay? Calculate the wavelength. By this time you already know, I don't need to tell you. So wavelength is equal to velocity wavelength times frequency. When you make wavelength a subject, it comes to velocity over frequency. I think I've taught you this already, how to do the subject. So velocity is equal to, what's a wavelength? What's a velocity? You come to your question there. Now you look at this. Have you seen this? This one is different because they have given you the speed. So you don't use 3 times 10 to the power 8. Why? Because the speed is already given, you see. And it is a sound wave. You see? Sound wave, the speed is different because sound wave is not part of those 7 waves. I said when it's those 7 waves, that's when you put 3 times 10 to the power 8. But since it's sound wave, you use 6 times 10 to the power 5, since that's the one they've given you. So that's the one that they've given you. that is 6 times 10 to the power 5 over the frequency. The frequency I think they gave you also. The frequency is this one here. 7 times 10 to the power 9. So, okay, 7 times 10 to the power 9. Okay, that's the frequency there. So what do you do? So I'll push this calculation this side. So if I cancel 5 there, what will remain is 10 to the power 4, because when 5 comes out, look at this is 10 power 5, this is 10 power 9. So when you cancel out 10 power 5 in 10 power 9, 10 power 9 means that there are how many zeros? There are 9 zeros, but I've cancelled out 5 zeros from the 9 zeros. So it means on top there, it will be 6 remaining since 5 has come out. Down there, it will be 7 times 10 power what? 4, because 5 zeros have been removed from the 9 zeros. Okay? And then that is 6 divided by 7,000. Okay? You can use a calculator to now divide this now. Okay? When you divide this, the answer you get there using a calculator, meters. That's how you solve these kind of questions. Okay? Okay, now you can have an exercise. You have to finish that answer. Use your calculator. Now this is an exercise. Question 1. An okay, a ultraviolet wave passes through water and kills bacteria at a frequency of 40 kilohertz. Find the wavelength. Okay. Question 1. Question 2. Gamma radiation is used to treat cancer. Is used to treat cancer of patients at a frequency of 54 megahertz. Find the wavelength. Question 3. A noise wave is heard when there was a car accident at a frequency of 20 kilo Haze. No, at a frequency of 20 times 10 to the power 6 Haze, and a velocity of 3 times 10 to the power 2 meters per second. Calculate the wavelength. Calculate the wavelength. Okay, those 3 questions you can do. Try them out. It's the end.